Yeah, most junkyards you can go to. You have to go in, you pick out what you need to, you go up, then you pay for what you take. Generally speaking, very much less expensive than brand new parts.
Because they're almost all like...
Yeah, they're all used stuff. But the
Yeah.
good news is some stuff like the steering knuckle, like this thing, right? It's going to be maybe a little oxidized or rusted. You can take a wire wheel to that, clean that up, and it's good to go. Okay. Now, obviously, I wouldn't use a wheel hub or anything along those lines, or a bearing, because again, I don't necessarily know how long that's been in there. But for the actual like physical component there,
Is that where you got this stuff from?
I got it from just vehicles and things over time. Yeah, it's kind of crazy.
How about like a bumper?
Yeah, a bumper would work too. All right, so well, let's just get into this. This is an upper control arm. Okay, it's a different type of shape. Okay, I got my bushings in here. These are the bolts that actually would pin that into the frame. Okay, so this is actually going to be pivoting up and down like this. Here's my ball joint. This is essentially pressed into this upper control arm, and there's no way to remove this. So when I needed to replace this part, I bought the whole brand new thing, the whole thing.
What'd that cost?
Okay, I forget what I paid for it, but you can see here how this boot is separated completely from that. Okay, and you can just see how
That's the old one.
absolutely floppy this thing is, right? You can actually, if you look into this,
Best visual.
you can actually see the ball if I wanted to. I could probably take this out. It's really bad.
Come
I
on,
was driving around on this thing. This came from my F-150 back in the day.
What?
It was severely in need of repair. But this is a good idea too to kind of look at the bushings. Bushings in this case was actually in really good condition. Nothing too crazy. Yeah.
Mason Ratzel is calling me.
I don't care. Don't answer. All right. Anyways, there's your control arm. Again, steering knuckle in this case. This is pretty heavy. So if you have an opportunity to take a look at this and pick it up later, just be mindful there are some sharp stuff on here, so you don't want to willy-nilly this thing. But I've got 2 holes here for my caliper for my brakes. I've got obviously my wheel hub here with the wheel studs that I mount the tire to. Wheel bearings pressed into this. There's a snap ring that holds that all together. There's our wheel speed sensor. Okay, I've got a ball joint down here that I actually literally had to cut off because I couldn't get out. And then this is a place where we put the strut, which we'll probably hopefully talk about today. So kind of fun. Definitely get some curls in that. Fatigue that out. I got some other things in here as well. This should be a new ball joint. Oh no, this is a bushing. Look at that, new bushing.
Oh, nice.
So this is perfectly brand new. You can see it's got a metal casing on the outside. It's also got a metal inside, so I can throw that bolt in there. But this whole polymer is going to twist and deform as that control arm is moving up and down in the suspension system. So that's fun.
So those universal, can those go on any car?
Technically speaking, they're universal. Yeah, they're not necessarily made for manufacture, but you're going to want to obviously pay attention to the sizing on that. Is this another bushing? Yeah, that's another bushing. I don't have a brand new ball joint. Typically, there's part numbers and whatnot that you can look up, usually on Identifix or whatnot. You go into a catalog. They can tell you what you need to get order, and then there's different manufacturers from third parties that you can actually go in and purchase that part number from that. Okay, so kind of fun. Obviously dirty too, so just be mindful of that. All right, today we're going to be talking about a bunch of other random stuff and then getting into other types of suspension styles or configurations outside of the torsion bar that we've already previously talked about. But picking up where we left off, yesterday we're talking about sway bars, more commonly, well I should say, they're technically called stabilizer bars, more commonly called sway bars. Okay, so most suspensions are going to have a stabilizer bar to reduce body roll. What is body roll? It is the lateral movement as you are turning the car. Okay, so not only is our suspension system worried about keeping the tires on the ground, the chassis off the ground, as you're going down the road, right, all the bumps and stuff, that's vertical suspension. We're also concerned about weight transfer, because that's happening also. So not only are we talking about diving when we're braking or we're squatting when we're accelerating, but when we're turning, we're shifting that weight side to side as well. A stabilizer bar is going to essentially link up your left side and your right side suspension systems, so that way that weight is not as easily transferred from one side to the other, and our suspension system can react to that. Yeah.
Our sway bar is one of those parts where that don't really go out before the car does.
Yeah, I mean, just to be completely upfront with you guys, a stabilizer bar is nothing more than a lateral torsion bar. It's a spring, and it's going to be twisting, but it's going to be twisting from left to right instead of front to back. Normally speaking, on your torsion bar suspension, the torsion bar is going to be going from front to back in that direction, in that axis. Sway bar, stabilizer bar is going left to right.
Is that only on trucks?
No, every vehicle is going to have a
Every
stabilizer
vehicle.
bar.
No. A torsion bar.
Typically speaking, it's probably a spring that's going to be used in heavier duty applications. I'm saying that in quotes because a truck is considered light duty, but it's
Like
not as light duty as like a Probe or Intrepid, right? But yeah, you probably find it more commonly in those applications. Anyways, in modern day vehicles, we actually are starting to see stabilizer bars not be a thing.
What?
Which is kind of interesting. Now, we still obviously want to have our suspension system have an anti-stabilizing, or I should say a stabilizing effect as we're turning. It's just now we're seeing electronic controls on suspension systems. So it's actually computer controlled suspension with different types of G sensors and whatnot. And then the computer can actually enact the suspension to be able to counteract roll. It's a lot more sophisticated solution to the problem, but it does eliminate weight on the vehicle and basically allows that in the hands of a computer system, which can enact and react much quicker. But this is a very manual, analog way to deal with sway. Yes?
How does all this electronic stuff not just destroy itself after water?
To be fair, it actually is much more reliable because it's it's sealed up, right? Computer systems communicating. So I don't know, it's nicer. We're not going to get into the weeds on the electronic controlled suspension systems because that's going to hurt your brain a lot. We'll touch base with it a little bit later, so maybe we'll bring that up then. Yeah.
On the electronic part of things, there was a 2025 Escalade, like the big ones,
Mhm.
and it has a night vision camera
Mhm.
in the front, and it was shattered. It's like a $3,000 camera.
Yeah. Yeah, not
And
cheap,
It took us like 10 minutes to replace.
right?
You literally just took the front panel off, dropped it down, unplugged it,
Re-
pulled it out.
Replacing a camera on a car like that one, super easy to do. Problem is everything else that comes after that. Because now that probably ties into your ADAS system, so you got to recalibrate. And if you don't recalibrate
So
that
you're telling
properly,
me
park
this is like
assist,
ECU?
lane departure, like cruise control, or you should say your like automated cruise control type stuff, that's going to be all off.
My dad's car is so nice, but I can't look at it.
Yeah.
It's a Mazda CX 625, Mazda CX-5,
Yep.
24.
And those are the type of things that we're not going to touch in high school.
Yeah.
That's stuff that you're going to be going to like tech college to learn about those systems more specifically.
Because it's got like
It's
got the cruise control, it's got like the lane assist.
Yep.
And then it's got like you can set it if you get too close to the car to like keep you at that
Adaptive
distance.
cruise control.
It's like
Yep. But all that works with cameras.
Yeah, exactly.
Yep. You can't take a wrench out and fix that. That's all computer programming. So it gets very nerdy very quickly.
The only thing I like, obviously I have to change the oil, change the headlight, and then was change the turbo. That's the only thing that we could like figure out.
Right. So this is the reason why too that you're going to take your vehicle to the dealership for someone who's going to have the tools, equipment, and training. You're going to be paying through the nose through it. This is why auto techs can make $100,000 plus, but it requires a lot of education and learning and understanding how these systems work first, and then we can start getting into how electronics and stuff can essentially make it better. right? And I know some people might not say it's better, but it honestly is. All right, anyways, stabilizer bars. Again, they're a lateral torsion bar. They go from the driver's side to the passenger side to connect that sides of the suspension system. You're going to have a stabilizer bar for the front 2 tires. You'll have a stabilizer bar for the rear 2 tires. Okay, and again, that's going to affect everything along those lines. He's right. In regards to that. Now, again, bringing this back in, just like how we have bushings on our control arms that allow for the pivoting of that control arm, we also are going to have some bushings here that we have to maintain, and we have to make sure that we are monitoring and inspecting, because those bushings are essentially how it's mounted, this torsion bar, to the frame of the vehicle. And they do go bad. These are much easier to replace, because typically speaking, you just take a couple bolts out and you can actually peel them off without necessarily completely uninstalling the stabilizer bar, and then you can put that in. And the same rules apply for this bushing. We don't want to use petroleum-based greases or lubricants. We want to use silicone when we are installing that stuff. So that's for every bushing. Yep, all the time. So kind of fun. Also, a fun little fact about the stabilizer bars. There's again, we have our bushings. The stabilizer bars can be modified. It's probably one of the easiest things you can modify in a car, because you can go out and literally just buy a larger diameter sway bar, stabilizer bar, right? And the larger the diameter it is, the more force it takes to twist that, which means the less likelihood that that force is going to be easily transferred through. So that means your car is more stable around high-speed corners. All right, we don't want swaying. We don't want that weight to transfer as easily. So the stronger the spring, the rougher the turn is going to be, or excuse me, the rougher the ride's going to be, but the more stable that car is going to be around corners. So for race cars, boom, get a bigger stabilizer bar.
Or just slow down at corners.
Or you could just slow down the corners. Who wants to do that?
I just pull my ego.
That is boring. Okay. Now, because the stabilizer bar is actually linked up with your suspension system,
It's the easiest way to go around.
it's typically going to be joined up with your lower control arm. Okay. So here's my stabilizer bar. Okay.
Until you get to the stop sign.
And then here's my lower control arm. In between those two, I have what's called a sway bar end link, stabilizer bar end link. This is essentially a rod. It's bolted here into the control arm and it's bolted up here to the stabilizer bar. So what ends up happening is actually kind of fun. As the tire is moving downwards, the control arm moves down, which then pulls down on the sway bar end link, which then pulls down on my stabilizer bar. And because that pulls down on it, it twists the stabilizer bar, which then on the opposite side pulls up. Opposite of that, right? So if it's going down, it's going to go up. If it's going to go up over here, it's going to go down over here. So that means if this tire is moving down here, it's moving up over here, and vice versa. So if I'm making a corner and my car's starting to lean, right? Tire's going up here, I'm going to push the tire down here. So that means my tire is going to contact down here. I have more contact, and then that means I have more grip. That's usually how that works. Okay, so that's how that torsion bar is able to actually function, by connecting with our control arm. But anyways, we still have bushings. We have sway bar end links. Again, here's kind of a closer up image of that bushing attaching that stabilizer bar there. Okay, so again, lots of different parts, right? We got lower control arm, we've got upper control arm potentially, we've got bushings, we got ball joints, we got steering knuckles. Okay, we got sway bars, we got sway bar end links.
Torsion bar.
Right? There's a torsion bar is a spring in a type of suspension system. Now we're going to get into the McPherson strut, or a strut type system. So this system is set up a little differently. We're going to still have some very similar parts, just the location of the spring and the shock absorber and some components are going to be missing on this one, okay, in comparison. So what is a McPherson strut suspension system? Well, we're going to eliminate the upper ball joint and the upper control arm. So this particular suspension system doesn't have neither. We still have a lower control arm, but we don't have an upper control arm or an upper ball joint.
Where'd it go?
Okay, it just disappears. It's not needed in this
Is
case
the up-
because my strut is directly attached to my steering knuckle, and that takes up the geometry of the upper portion of that suspension system. Okay,
crazy.
so the strut, as we're going to talk about here in a little bit, is actually taking place of it's going to do the same job as the upper control arm in the upper ball joint. Okay. Now the nice thing about the McPherson strut setup is less parts means it weighs less. It also allows us to have more engine compartment room. So these are typical suspension systems that you're going to have on a front wheel drive car. Because now you have a larger engine compartment, you can actually transversely mount the engine, which is what is needed for a front wheel drive vehicle. Okay?
Transversely. It's in there backwards?
Transversely it's side to side.
Oh.
Longitudinal is for a rear wheel. That means it's going facing front to back. So side to side. So we need that larger engine compartment. If I have a rear wheel drive vehicle, I don't need as large an engine compartment because it's going front to back. So again, this is where you typically would find on a front wheel drive vehicle. All right, again, a McPherson strut contains a spring, upper suspension pivot, or a mount, and a shock absorber. So this is kind of the difference between a strut and a shock absorber is actually more significant than what you might think. Because again, on a torsion bar suspension, I have a torsion bar spring, and I've got a shock absorber that's mounted in two different spots. They're separated from one another. Okay? Where in this case, we've actually gone through the trouble of combining them both together. So we essentially take a shock absorber, put it on the inside of the coil spring, okay, and then we basically use that to mount it onto our suspension. Now, this isn't important for a test or anything, but I do need to communicate this with you. A strut is going to be much more beefier than a shock absorber. Okay, just because of the types of loads, the lateral loads that are going to be encountered when turning. So it needs to be accounting for that extra force. So it's going to be a little bit more rigid and thicker, if you will, larger diameter in regards to its shock absorbing ability than just a standalone shock absorber. Okay. The strut is also not only going to contain a spring and a shock absorber, quote unquote, it's also going to have areas where we're essentially just seating the spring and mounting that there. So that way it can kind of do everything all at once. Okay. So upper strut mount. The bushing or bearing plate is the load carrying member in this type of system. So again, here's the top of my spring in my strut. The weight of the vehicle is going to be placed on the top of the strut. Now, as my vehicle turns in the front wheels, I have to pivot that strut. So I'm actually going to have in this particular piece, is that it? That's got to be it. A bearing. Okay, that bearing is going to allow for that strut to
bearing's one down.
pivot.
It's on top of something else.
It's probably got this little flange on it.
Yeah.
Looks like a can of tuna.
You look like you can.
Oh, thank you. I don't even know what. Okay, so I got a bearing. Although some of these bearings don't look very big on real life, but again, if I don't have an upper control arm that's going to be taking into account the movement of the geometry, right? I've got to allow for twisting and turning. So because we don't have an upper ball joint, that's what this is going to end up doing.
Are upper control arms like mostly structural, or are they like?
They're structural for the geometry of the suspension. Yeah. So as stuff is moving up and down, it maintains that geometry.
It helps with
vertical.
lower.
Yes. So think of it kind of like a parallelogram, right? That's constantly changing. So that way, we'll get into this when we talk about short long arm suspension. The control arms can actually just focus in on the movement, while your spring and shock absorber can just be essentially focused on the absorbing
Parts don't
and
have to multitask.
right. Where on the strut here, the strut is literally doing everything. It's not only the structural part, so it's allowing for the movement up and down, but it's also for absorbing the shocks and jumps and rebound and everything like that. So ultimately what I'm trying to say is that this particular type of suspension system doesn't have the same type of performance that you would get out of a short long arm or a suspension system that would be typically designed with an upper control arm. Okay, but because these are typically on smaller vehicles, they weigh less, we're more concerned about miles per gallon than we are horsepower and performance. This is wholly adequate and actually does a great job for what we want it to do. Alright, strut dampens like a shock absorber. It locates the spring because it seats it. And it sets the position of the suspension system. So again, we're multitasking on this particular type of suspension system. All right. And again, I want to emphasize that struts are different than shock absorbers. Even though they have the same function, right? They are wholly different. You would not want to substitute a shock absorber in a strut. Okay. Now, fun part about this is a lot of times you can actually get aftermarket replacements for these struts. You call them coilovers, right? Probably you've heard of coilovers. Why is it called a coilover? Because it's literally a coil spring over a shock absorber. Okay, that's what it is. But again, you can come in here and you can modify that with different types of springs. A variable type of spring, you can actually go in and adjust the preload on those coilovers, so you can change the effect of how that is going to perform. So again, if I'm going out to Road America and I'm racing around the track, I'm going to want to stiffen up my suspension so I can feel the road. I can actually lessen the weight transfer, so that way I can get the best grip possible out of my tires, so on and so forth. But then I can go drive home, loosen up that suspension for a much more comfortable, smoother ride, where I'm not interested in that sort of stuff.
Getski, what do you get miles to the gallon?
Just kind of random. Usually between 17 and 20. There we go. That's pretty typical for a 4Runner. Okay, short long arm suspension. If you're looking for performance out of your suspension system, this is typically what you would end up finding. Okay, this is a double wishbone suspension. Oftentimes, what you'll end up calling is the A-arm or the A-frame. The control arm is sometimes called a wishbone. If we have a double wishbone, it means that we have a lower and an upper control arm.
I did. Why'd you call me?
So again, this is one thing to keep in mind, that with the short long arm suspension system, you're isolating the responsibilities of the suspension system. So the travel is dictated by the upper and lower control arm, and the actual absorption of the energy is going to be in the spring and the shock absorber. So that means each one of those components can concentrate on what it needs to do, and because it works together, it's more effective at that. So you're going to have higher performance. The problem with this is that short long arm type suspension systems do take up more space on the vehicle. So oftentimes, if it's not included, it's just due to the fact that they don't have space for this. It also weighs more because there's more parts. Okay, but again, we're looking at performance on that end.
Is it more effective generally?
Yes.
Than most effective?
Yeah. If there's a vehicle out there that has a double wishbone suspension system, it is a better suspension system by design. Okay. And I use the term better in regards to performance. Okay, it's going to have a better ride quality. It's going to have better transfer of weight, or better resistance of transferring of weight. It's going to keep the wheels on the pavement quicker. It is just overall in comparison to other suspension systems, this is the one you want to have. Again, there's an asterisk on that particular thing. But again, other names for short arm, long arm suspension: SLA, short long arm; A-frame, double wishbone suspension. Make sure you get that down. The different names for the short long arm: SLA, A-frame, double wishbone. Okay. All right. All right, again, in the double wishbone style suspension, dampening is done by the strut and the stability is done by the control arms. And since duties are not shared, the strut can do its job, the control arms can do their jobs by specializing in their parts, which means more stability, which means better ride quality. Okay, which is kind of fun. And again, here's just a couple examples of this type of system. Okay, I got a strut that goes in here. I'm going to have a upper control arm here, lower control arm down here. My steering knuckle is a little bit more elongated than it would probably be on the other systems. But again, all that stuff's going to be working in harmony with one another.
What are you looking at?
Reflection in the window of a window. Okay, strut rods. Sometimes we're going to have an upper control arm, but sometimes we're not going to necessarily have a distinct lower control arm or an A-frame, okay? So for instance, if I got my lower control arm like this, it's kind of all one in unit, like so. But I don't know if I have a strut rod on this. No, I don't. Actually, there we go. That's an oldie right there. You can see that bushing right there? That's garbage.
I'm not gonna start until that.
Anyways, that lower control arm. Your lower control arm is just, instead of an A-frame like this, with the ball joint and bushings, it's just basically one piece. We have a ball joint on this end, we have one bushing on this end. Okay? Now, in order to make sure that the geometry is not shifting laterally or back and forth on this type of system, we have to include what's called a strut rod, or basically a second mounting point, okay, to create kind of this A-frame type shape. So it's in combination. So you can see here on this particular picture, here's my lower control arm, right? But then, let me get a different color. Hopefully this shows up. My strut rod is a second mounting spot right there, so then that way this tire can't shift back and forth. I wouldn't want to have that happen. And if I didn't have that strut rod, there's nothing that prevents that tire from shifting forward or backwards as we're moving through. So just a different configuration. Okay? Instead of having an A-frame lower control arm, it's a strut rod that's joined up to the steering knuckle and works in combination with the lower control arm. Did you have a question? No? Okay. Again, lower control arms that don't make use of an A-type shape. All right, air suspension. So these don't actually have a quote-unquote like metal spring. Instead, we basically just have a very highly reinforced rubber balloon, okay, that's inflated, and that it's basically riding on a cushion of air. So you can imagine immediately the ride quality that's going to be taking place in this particular type of suspension. It's going to be very comfortable. You know, it's still going to absorb shocks and whatnot, right? And that's going to be transferred into that balloon before it gets up into the chassis. And what's really cool about this particular type of suspension system, it is able to be adjusted as you are driving down the road, right? There are literally ride height sensors on the vehicle that's measuring how far the chassis is off the road. And as it's going around and measuring this, it can actually inflate or deflate how much pressure is on the inside of this balloon, essentially, to give you stiffer or more comfortable ride qualities. Okay, so if I had this type of suspension system in my vehicle and I put it on sport mode, man, we're going to inflate that up much harder, right?
It's a lot of height, but not much different.
Right? Oh, hey, I'm driving down the highway at 70 miles an hour on a really flat, smooth road, right? Not many bumps. I can soften that up and cushion it maybe a little bit more. Now I'm just kind of gliding through. So there's different advantages to this one. It's a little bit more technical, okay? People are always afraid, well, what happens if we poke a hole in that? Well, then you can't obviously have air pressurizing in that. But again, that's not something that you're just going to be able to take like a pin in like a balloon. This is much thicker than that. It's going to take a lot to pierce that.
It's like a tire.
Basically.
Why is air suspension only like aftermarket most of the time? Because I don't see it on.
Well,
New trucks come with this.
yeah, trucks are going to potentially have it. You could potentially also have it on like vans. I've seen it happen, but it's nice because if I just got leaf springs, let's say on my pickup truck, that's rated for X amount of pounds, right? As soon as I put weight on the back there, what's going to happen to my truck? You're going to start to squat down, right? Because that spring is only going to be able to carry so much. Well, on an air suspension system, boom, I start to squat. Okay, let's inflate that bag harder, man. It brings that back up to the correct ride height. So it's not that it's not from factory. It is. It's just not as common because it's a little bit more fickle, if you will. It is a little more expensive. Okay, a little bit more quote unquote sophisticated than your typical just, hey, let's throw a spring on it that's rated for X amount of pounds. You also have to accommodate for the air compressor that needs to inflate these or de-inflate them. So it's, although you could theoretically use what my old van had. My old Sienna had a coil spring for normal operations, but it had a bag inside that. And if you were going to be loading up the van, they literally had like a little Schrader valve that you could inflate just like you would like a tire.
Really?
You could actually increase that bag on the inside coil spring to increase the weight carrying capability of that.
Was it?
Where was it?
Where was the valve?
It was like right on the bag on the suspension system.
Okay.
You had to like crawl around and hit it. It was
What were
weird.
you carrying
I
in
never used it,
How was
but
it
it was
called?
available. So it's just kind of it was one of those fun
in
things.
your minivan, guys?
I was carrying half a Circus.
What?
All right, active suspension systems.
Go start your trunk, buddy. Yeah.
This is where we're just going to kind of touch on some very technical stuff. I'm not going to get too much into depth with this, but we're starting to see higher end vehicles, luxury vehicles that actually technically don't have springs in their suspension systems. They don't have airbags. Literally, their suspension system is controlled through magnets. As weird as that is.
Do they like use?
So you're going to still have like cans like this, but you're going to have magnets. So you're going to have a magnet, and what happens to magnetic poles that are the same?
They push away.
They push away from one another, right? So technically speaking, what's going to happen is we're going to put a magnet in here that's going to ride on top of that magnet system. So as this is moving up and down, right, they never actually touch each other, and they constantly are pushing. Well, I can actually, again, actively adjust this type of system through like electromagnets to change the strength of the magnetic field, which allows for the dampening and the reaction of the suspension system to give you a much more active, comfortable ride. An adaptation to the conditions that you're driving in and your weight and the ride height. So this gets pretty crazy pretty quickly.
Does it really?
It does.
Like how crazy?
like pretty crazy.
Like effing crazy?
I wouldn't go that far.
Like.
But again, MagneRide regulates the flow of magnetological fluid. Again, you don't have to write that down. We varied the magnetic field produced by a small electric coil mounted inside the shock that changes from a fluid to a semi-solid instantly and directly proportional to the magnetic field applied. And again, the response time on this is 5 milliseconds. So I can literally change this and adapt it 5,000 times a second, which is kind of ridiculous how fast we can adjust this stuff.
How many milliseconds is in a second? Probably harder.
Well, how much how much millimeters is in a centimeter? Right, you can kind of, it's metric on that end.
I don't know.
All right, again, sensors on active suspension systems include steering angle sensor. Hey, am I going around a corner? Right, this would eliminate a stabilizer bar because if the computer knows you're going around a corner, it's going to stiffen up one suspension side and soften the other side. So it can independently control your suspension. You have roll sensors, again, how much roll is happening. Lateral acceleration. Side to side. G sensors, hey, am I stopping really quick or am I accelerating really fast?
Yep.
Again, it can change independently your front suspension in comparison to your rear. So that way you constantly are even with the ground. You don't have to worry about dive and squat and roll and all this sort of stuff.
What's dive? Braking?
So during acceleration, the front of the vehicle lifting, that's going to be known as squatting. And the rear of the vehicle lowering at the same time, that's called squat. So again, this is typically under acceleration forces. All that weight of the vehicle is transferred to the back. So it's literally squatting down as it's going. Once you start to equalize the equilibrium out, it's going to balance itself back out. But we don't want squat because squat means less traction. Put the flashlight away. I can see you.
It's amazing. I
Okay.
don't have a Milwaukee flashlight.
So we don't want squat. Okay, because then all of a sudden all that weight comes off the front wheels, so now all of a sudden I can't turn. Active suspension helps eliminate squat by stiffening up the rear suspension and loosening up the front. And again, dive would be the opposite of that. Dive means all the weight's transferring forward, so my rear tires come up, pushes the front tires down. Couple tools that we're going to use. A dial indicator. We've already talked about this. You don't need to write this, or you don't need to draw this. There's the dial indicator. And then finally we've got our suspension wear indicator. This is a very fun tool.
Is it really?
It's like 65, 80 bucks. It comes from Germany. You are going to be using this while we are inspecting your suspension system, specifically the bushings on your vehicle.
That's the exact one you have.
That's the exact one I got. The Mueller Werkzeug is worn off though.
That's definitely English.
But essentially no, it's German.
I feel like I could make that.
Typically what happens is you have your tire that you put this underneath the tire and then you rock this handle back and forth and it puts added strain on the bushing so you can see if you have a loose bushing, you can visually inspect it. It's very obvious. We've done this on bad bushings before and it's just, hey, the bushing's bad. It's not hard. Anyways, that's all I got for you guys today. We got through it. Fantastic. Yep.
Well, I got to fix some of it.
What we're going to do is we're going to give you guys the next 3 minutes. 3 questions about anything that we talked about today. Did I talk about something that maybe you're curious more about? Hey, we talked about active suspension, Mr. Getsky. I'd like to know more about that. I have questions about that. How does this interact with X, Y, and Z? Right? Do you still have control arms with an active suspension system? Right? Is it a strut or is it something else? Again, you could come up with your own questions on that. But I'm going to end the recording here and
See you later.
still recording.
Jetski, can you start?
No.